Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 1, Exponents, Lesson 9a, which is a little bit more about negative exponents. So let's just call this more work with negative exponents. Okay, complete the following table by evaluating each expression for the given value of n. Now, n is what? A variable. So that means that it can represent a number. So I'm going to tell you what the number is that n represents, and we're going to apply it to the expression 2 to the nth power. And yeah, that is how you would say it. It sounds weird, right? 2 to the nth power. But so when n is 3, 2 to the nth power is 2 to the third power. So you would evaluate it 2 times 2 times 2. And here I use parentheses to show I was multiplying. But for the next one, I'm going to use dots because I like dots. So now my n is 2. I have 2 to the second power, which is 2 times 2, and evaluate it to be 4. 2 to the first power. Well, I could write it 2 to the first power, or I could just write 2. You know me, I don't like ugly math, so I'm just going to write 2. Ha! 2 to the 0 power. When n equals 0, it's 2 to the 0. Whine, complain. I don't remember what that means. Yeah, okay, so let's turn back a couple of pages. And what does it mean to be a 0 power? Any base to the 0 power is 1. If you don't remember something, there's nothing wrong with flipping back to a previous lesson and looking it up. So 2 to the 0 power is 1. All right. Now, negative exponents. 2 to the negative first power. What is 2 to the negative first? It's not negative 2. It's not negative 2. Don't make that mistake. You'll look really foolish. 2 to the negative first power. Now, the base here is 2. So what I need to do is make that a fraction. So that's equal to 2 over 1 to the negative first power. Now, negative first power, what does it mean to be a negative exponent? Well, you make the base a fraction and then take the reciprocal of the base, i.e. flip it over and make the exponent positive. That was the negative exponent. So I have to take the reciprocal, I have to flip it over, 1 over 2, and it's going to go in parentheses. This should have been in parentheses too. And now, instead of a negative 1, it's positive 1. But I don't actually have to write that. I could just write 1/2. Okay, gets better. Negative 2. So base 2, exponent, negative 2. So 2 to the negative second power. I'm going to put that over 1. 2 over 1. And now I got to flip it over. And I get 1/2. Now instead of negative 2, becomes positive 2, which is 1/2 times 1/2, 1/4. Okay, the next one. 2 to the negative third power. 2 to the negative third power. Well, that could be 2 over 1 to the negative third power. I flip that over, and I get 1/2 to the third power, because once you flip it, it's positive. 1/2 times 1/2 times 1/2. Oof-ah. That is 1/8. Okay, not too bad. More with negative exponents. Use the laws of exponents to simplify each expression. All answers must be expressed using, and there it is, everybody's favorite, positive exponents. So any negative exponent, you have to reciprocate. You have to flip it over and make it positive. So for this one, 1a, I'm going to rewrite it, keep the base, 10, and subtract the exponents, top minus bottom. 4 minus 8. And I get 10, 4 minus 8, to the negative fourth power. Oh, so that means it has to be 10, sorry, I gotta write that in black. 10 to the negative fourth power over 1. I can reciprocate that, flip it over, 1 over 10, and now the exponent becomes positive 4. Oh dear. Do I need to evaluate this? Let's look at the directions. Use the laws of exponents to simplify the expression. Positive exponent. No, I don't have to evaluate that. I could get 1/10,000th. I'm not going to because I don't have to. For this one, all right, the whole base is m, and the laws of exponent, so this was the quotient rule, subtract. This is the power rule. It's a power to a power. When the two exponents are close together like this, that's a power rule. So it's m to the negative fourth times 3. All right? Power rule. Multiply the exponents. So m and negative 4 times 3 is negative 12. Negative exponent goes over 1, and you reciprocate it. 1 over m. And then instead of negative 12, now it's positive 12. So put a little box around it because that's a positive exponent. That's all I needed. Okay. This one, this is also the product rule. I'm going to keep the base. Right. Product rule is when you're multiplying. Power rule is when you have a power to a power. This is the product rule. So keep the base and and add the exponents. So negative 2 plus 3. Oh, let's see, what's negative 2 plus 3? The signs are different, so you subtract 3 minus 2 is 1. And when the exponent is going to be whatever the higher number is, so 3 has a higher absolute value than negative 2. 3 is bigger than 2, you get 4 to the first power. And that's it. It's just 4. Because remember, when it's to the first power, you don't write it. All right, next, you do this is the quotient rule. So you're going to do the top minus the bottom. Keep the base 5, subtract the exponents, 6 minus 9. All right, so then you get 5 to the 6 minus 9 is negative 3. Now that goes over 1. As soon as you see that next negative exponent, you go, oh, got to make it a fraction, over 1. And then you flip it over and make it positive. Because I just flipped for positive exponents. Oh no, that was just bad. I know. 1 over 5. Instead of negative 3, you get positive 3. Power to a power is the power rule. Keep the base, multiply the exponents. 7 times negative 2. Actually, I'll put that in parentheses. 7 times negative 2. So you get p to the negative 14. Did I just write a 4? Yes, I did. Negative 14. So as soon as I see that negative exponent over 1, and I flip for those negative exponents, you get 1 over p to the positive 14th. quotient rule, power rule, product rule. Keep the base, and you're going to add the exponents. Negative 2 plus 1. Negative 2 plus 1. All right, the signs are different, so you subtract. 2 minus 1 is 1. And negative 2 has a larger absolute value than 1, so 2 is bigger than 1. 2 is negative. That means the whole answer is negative. So 6 to the negative first power. The 6 is positive, but the exponent is negative 1. Oh, it's over. It's got negative. I got to flip for negatives. So I'm going to flip that over and get 1 over 6 to the first power. But you don't have to write that 1. When you have a 1, you don't have to write it. So you just get 1/6. Okay, I went through that kind of fast because I want to actually take my time on the next page, and I don't want the video to be really, really long. Ugh, look at this hot mess of a paper here. So much work. Now remember, when you have the power rule, you're going to have to distribute it to everything inside the parentheses. So this is going to be keep the base x squared, but now I have to distribute this negative 4. It goes to the x squared, and it goes to the y to the negative 3. So I'm keeping both of those bases, keeping the x squared and keeping y to the negative 3. Now I have to multiply it times the exponent, negative 4. So squared times negative 4, negative cubed times negative 4. All right. I have this base x, 2 times negative 4, negative 8, times y, negative 3 times negative 4, positive 12. Okay, the only part that goes over 1 is the part with the negative exponent. This does not get changed. This, with the negative exponent, goes over 1. When I reciprocate that, and only this, I get 1 over x to the 8th and the y to the 12th. Now, that's when it goes over 1. Multiply straight across. 1 times y to the 12th, y to the 12th. X to the 8th times 1, x to the 8th. So basically, I could have skipped this whole middle step. I could say, oh, x to the negative 8th, that's going to become x to the positive 8th in the denominator. Y to the 12th is already positive, so it stays in the numerator. Let's take a look at the next one. So I have, again, 2 different bases, m to the negative 5th times y squared. So I'm going to take this negative exponent and I'm going to distribute it and multiply negative 5 times negative 2 and 2 times negative 2. Negative times negative, that's going to be positive m to the 10th power times y to the 2 times negative 2, negative 4th power. Oh, the bit with the negative is going to be in the denominator. So m to the 10th power over y to the 4th power. Remember, once it hits the denominator, it becomes positive. Oh dear, my, oh my. This is quite a bit going on here I have to unpack. So first, I'm going to start with the coefficients. I'm going to pull those front and center. Negative 15 divided by negative 3. And then I have these w's. I'm going to keep the base, w, and I'm going to subtract the exponent, top minus bottom. Negative 6 minus negative 2. That's going to be a keep, change in a minute. And then x and top minus bottom, 2 minus 2. Oh, golly, look, this is going to be a lot, isn't it? Negative divided by negative is positive 5. So my coefficient, positive 5. Negative 6 minus 2. Keep, change. So negative 6 plus 2. Different signs, subtract, keep the sign. So it's going to be w to the negative 4th power. 2 minus 2, x to the 0 power. All right, some stuff has to happen here. These are all kind of separated by multiplication. This w goes over 1. That's the only part that goes into the denominator. So now I'm going to have 5 on the top and w to the 4th on the bottom. And what is this mess here? X to the 0 power. We talked about that. That's 1. We're multiplying that times 1, which means, nothing changes. So I get 5 over w to the 4th power. Remember, anything to the 0 power is 1, but only the part to the 0 power. Negative exponent becomes positive in the denominator. Let's take a look at the next one. First, I'm going to pull the coefficients to the front. 27 divided by negative 9. Then, for the base y, I'm going to subtract negative 7 minus 2. Negative 7 minus 2. And then the next bit, keep the base z, and I'm going to do 4 minus 4. I already know where this z is going. 4 minus 4 is 0. I know that's just going to be times 1. So we'll get rid of that in a minute. 27 divided by 9 is 3. 27 divided by negative 9 is negative 3. Y. If I do keep, change here, negative 7 plus negative 2. That's going to be negative 9. 4 minus 4 is 0. Z to the 0 power times 1. Put the part with the negative exponent over 1, and that's going to flip. Just this part flips. So, negative 3 times 1 over y to the positive 9th. Or I could just do negative 3 over y to the 9th. What happened to the z? 4 minus 4 is 0. Z to the 0 power was that times 1. Okay. Those were hard problems. It gets a little easier. For this one, I'm going to separate out the coefficients. 3 times 2. Keep the base d. Negative 4 plus 2. 3 times 2, 6. I wrote negative 2 plus 2. It's supposed to be negative 4 plus 2. Negative 4 plus 2 is d to the negative 2nd power. And remember, when it's a negative, it goes in the denominator. So I get 6 over d squared. And that's it. Not too bad. This last one is very similar. Separate out the coefficients. 3 times 4. Keep the base m. and add the exponents. -1 plus -2. 3 times 4 is 12. -1 plus -2, m to the -3. Only that part goes in the denominator, so you get 12 over m to the positive third power. All right, we're going to do some more practice with these problems. I'll talk to you soon. Bye.